Alright, in the previous video we actually stopped here at this thing, and we say that we're gonna derive this thing, alright, into equation 1 and equation 2. Alright, but however, after doing a certain stuff, I realized that equation 2 is actually redundant, and in fact it's also not correct. Alright, so I'll just simply prove to you that the equation 1, how do we get the equation 1? Okay, so I'll just simply copy this thing. Alright, and I'll just, actually don't need to copy I'll just show you So this thing over here, I purposely broke it down into two terms instead of writing of like this. Is because I just want to move them over to the other side in a correct way, because the convention will actually cause things to go a bit different. Alright, so this is why I bring it down into this form and this form. So if I were to bring it to the other side, I have become positive. This thing bring over to the other side is negative. It's very clearly seen, as you can see, right? So this thing over here, if I bring it to the other side, it is positive now, as you can see. If I were to bring this thing over here to the other side, I'll have a negative sign, correct? Next, I'll bring this t over 2 uk plus 1 to the other side. Alright, so therefore I'll have a minus t over 2 uk plus 1. You see? So after rearranging, alright, into this form, I'll call this equation 1. Okay? And the next question you may ask is, why do I bring this thing to the other side? And therefore, I don't know. I really seriously don't know. But I just can spawn out certain understanding is that this is Euler's formula. Alright? In terms of time step k plus 2 and k plus 1 over t. So this thing over here is Euler's formula. Minus away t over 2 uk plus 1, which uk is your input. Alright? Don't confuse with ourselves that the convention, if you remember in the past we used uz over ez as a transfer function, is equals to hz, where this one is your input, this is your output. But in this case, if it's gz, alright, your uz is actually the input, yz is the output. Alright, so be careful of the uz convention. Alright, so this u is different from this u because this is input, this is output. Okay, and they are totally not related at all. Okay, it's just a convention that is talking. So this uz in our case now is an input. So if you were to head back just now to what I previously said, is that this thing over here is an input, and then your output minus away your input, or in other words your output minus away your input, you'll get your previous input, I think. But in any of the case, this thing over here, alright, is your x2, alright, k plus 1. Alright, and you may wonder what the hell is this thing suddenly coming up from where? From nowhere. Alright, because in the lecturer has actually told us that x2k, alright, where am I? Is equals to this thing over here. Alright, yk plus 1 minus yk over t minus 2 over 2 uk, t over 2 uk. Alright, you say that x2k is equals to this thing. Alright, but from nowhere, I don't even know how this thing comes about. Alright, if you think about it. Alright, if I were to paste this thing over here, let's ignore the equation 2. Equation 2 is totally useless in our case right now. Okay, so over here, as you can see, alright, x2k is equals to this thing. Alright, from here is the most similar step, is that this thing over here is Euler's formula. The only convention is this is plus, this is minus. So how did he know that this is plus and this is minus? Or how did he change it back to here? And these are the things, the question that arise from here. Alright, and you may also think in the relationship that maybe, hold on a while, I can shift the whole thing, alright, by a time step backward. Alright, so in other words, I'll have k plus 1, alright, instead of k plus 2, I have k plus 1 now, minus yk, instead of k plus 1, I have k, so I have a minus 1 time step delay, alright, or minus 1 time step shift, alright. So in case of k plus 1, I have uk, alright, so I have uk, sorry, I have uk is equals to, so instead of k plus 1, I will have k over t minus, instead of k, I'll have yk minus 1, okay, t plus t over 2, instead of k, I'll have uk minus 1. So I shift the whole signal back by 1, and I'll have this thing. and I call this the x2k. That's what he's trying to say if I think that's the case. The only reason that I can find in order to prove that the x2k is actually the same as this thing. Why it's exactly the same if I think about it. You see? It's the same definitions, right? Your x2k, where am I? Your x2k is equals to this one, while this thing over here that we've just derived is equals to the definitions is given. Alright? But to a certain extent, how can you so confidently say that it's x2k over here? And why do we change it by a time step shift? Things like that. But anyway, in any of the case, you would know that your x2k is equals to this thing. Okay? So if it's x2k plus 1, just simply everything plus 1. K plus 1 I'll change to k plus 2. K I'll change to k plus 1. UK I'll change to UK plus 1. Okay? Yeah. So if I were to copy this thing over at this side, okay, you just take a look. It's the same thing now, right? This thing over here is this thing. So I could say that this thing is x2k plus 1, okay, because it's a shift of x2. Alright, so these are the things that you may need to know. If you don't understand, you can just write it on a paper, or you can just rewatch, click a few minutes ago and rewatch. I'm just simply explaining to you that why x2k plus 1 is equals to this thing, or in a way that I don't even know why is it coming out, but I actually explained to you the concern of how does this come about, and you may need to know also. And eventually, if you in the future you are free, then you can find a way to see and explain why is it like this. Alright, because as what I said earlier, not because anymore. Alright, I took quite a while to explain to you that how we actually transform this thing into equation 1, and how we say that this thing over here is your x2k plus 1. Okay, let's just continue. So this thing over here is my x2k plus 1. Alright, I'll set it as equals to this thing over here. Alright, this thing over here is yk plus 1 over t minus yk over t. Alright, I can also rewrite them, alright, as currently what we're gonna do right now. Okay, so I'll rewrite them as a whole full fraction over t. Okay, so previously I rewrite as over t like that, right? So now I'll just rewrite as this form over here. Okay, and next is a form of a rearrangement. I'll copy this and paste it over here. Okay, as you can see, this thing that I'll just paste is part of the x2k. Take a look. Well, this is the form the thing that I've explained to you why I don't know how he derived that. But if you in the exam you really want to derive, alright, you can just shift the one that I say in a few seconds ago, or sorry, a few minutes ago. Okay, of how do we get back this thing. Alright, so just click a few minutes ago and just rewatch how I get this thing. Alright, because I forget to say. But anyway, so this thing over here is your x2k. Okay, it's something that he named it. Okay, so I can simply rewrite the term x2 this term in terms of x2k and this thing. So in other words, I actually bring this to this side. Alright, I'll bring this to the other side. So in other words, I'll have this form. Okay, you see, plus. Alright, so this thing over here, or in other words this thing now, if you see this is the same, alright, is equals to this form based on my x2, based on the equation that he's given us. Alright, so I can simply rewrite this stuff as it is equals to x2k plus t over 2 uk. Okay, so I'm gonna sub in this thing over here as that one, right, as this thing over here. Ta-da! Okay, so if I have t over 2 uk plus t over 2 uk, I would have t uk, and this thing over here I'll have x2k. You see, so this thing is the one that I will be showing you right now, that is changing from equation 1 to equation 3. So this whole thing, in fact this thing over here is equation 3. Okay, if you don't believe me, I'll just simply bring this down. It's the same. Okay, your x2k plus 1 is equals to this one, while this one over here is this one. Okay, so you think about it, this thing is the form that comes from, give me a while, that comes from here. So I will simply rearrange this thing into this one, into this form. Okay, so I'll just write it down the steps now. Okay, then plus t over 2uk. So if I were to add this thing up, alright, this is actually plus, sorry, is it? Yeah, this thing is plus because I bring this minus to the other side. So x2k plus t over 2uk is this form. Alright, so this thing is the same as this thing lah. Just, yeah. But anyway, this is the conditions. And if you add it up together, you have equals to x2k plus tuk, which is what I've shown you over here lah. Okay, I'm actually repeating the same thing, but yeah, I just want to show you that exactly this is this lah. Alright, so therefore this is the first one where I just found out my x2k plus 1 is equals to this thing. Okay, so this is my equation 3. Ta-da! Okay, now getting back to this equation 1 again. I know that this is my x2k plus 1. Okay, it's already straightforward already. It's given. Alright, it's this thing over here. Alright, previously was x2k. Alright, now we have x2k plus 1. It's the same thing. In other words, if you don't believe, I'll just paste it over here. Okay, so you can just simply compare. Alright, just take a look. Alright, this thing over here is this thing. This thing over here is this thing. Okay, so therefore my x2k plus 1 is this one. Okay, I don't know where is it coming from, but you just need to know it's coming from here. Alright, you need to know how it's being rearranged and how intuitive it is to you. Alright, how do you know? Because in exam different question ma, so you cannot straight away follow this type of step. It's totally redundant, but you need to know how to choose your x2, your x2k plus 1 and things like that. So this goes in terms of your practices and how do you read. But anyway, let's continue. So instead of writing this in terms of the one that I'll show you, right, if I have to copy this thing, yeah. So in the previous step, when we derive x2k plus 1, alright, we actually say that this thing over here, alright, or in other words, this thing over here is equals to this thing, right? Because you see, this thing is this thing, and this thing is equals to this thing. But it's derived from x2k, alright, this thing over here. Alright, I just simply shift this thing to the other side only. Alright, so this one will become positive, right? This equals to this. Alright, so therefore this, if I were to bring it out, okay, take a look. This thing over here is this one. Right, so I can re-represent this thing as this one ma. Right, so in the previous video we said that. So not previous video, previous part. Oh, I'm very shacked already. Alright, next, but in this scenario, we won't want to change this into this form. Alright, I'm not going to change this into this. I'll change this thing in terms of equals to x1k plus 1 minus x1k over t. Okay, by the given information that you know that x1k is equals to your yk. Okay, I also don't know where he come from, but you just need to know that x1k normally you just write it as equals to yk. Just you know, just take it lah, just life. Alright, so this thing over here I rewrite as this form, given that I know that x1k is equals to yk. So if x1k plus 1, then I'll write as yk plus 1. Alright, so yk plus 1 is this one. So I can rewrite as x1k plus 1, which is this one. Yeah? Shack, you know. Very shack. I also don't even know what the... Although I get the answer now, but I don't know what the meaning. But anyway, this thing over here is still the same. T over 2 uk. Okay? And next, I'll just rewrite everything in terms of x1k plus 1. Right? So I have x2k plus 1, which is this one. I'll put it over here. Okay? Alright? This x2k plus 1, we know that is actually equals to what? Is equals to this one. We have derived to you just now. Click back to about 9 minutes. If you were to click back to 9 minutes of this video or somewhere there, alright, you can finally know we have derived x2k plus 1 as equals to this thing. So now I'll sub in my x2k plus 1 equals to this thing, alright, as equals to that thing lah. Okay, so very shack already, you know. So I'll have x2k plus 1 as equals to this thing. Okay, next I'll just write in terms of x1k plus 1 lah. Okay, so what I'll have is 1. Okay, so this thing over here, if I'll bring it to the other side, is plus, right? So I have this plus over here. This thing over here, if I'll bring the other side, is minus t over 2 uk, which is yeah lah. So therefore, this thing over here, I just simply bring it down over here lah. Okay, so this thing is equals to your x1k plus 1. So I just want to write in terms sorry, I just want to write in terms of x1k plus 1. So I multiply everything by t. Okay, so this thing I will have t. This one becomes t square. Is it t square? Dun dun. It's t square. Okay, and this is t times t will cancel. Alright, this thing will become t square also. Alright, so now t square uk minus t square over 2 uk. What do you have? You have tx2k, which is this one. I bring it down. Okay, this thing minus this thing, I will have plus t square over 2 uk. Right, this thing over here plus minus this one, I'll have this one. Take a look. Okay, just take a look. Alright, and then next I'll have this thing over here as x1k plus 1, because I have also multiplied t with this t over here. Okay, if you think about it, I multiply everything by t, right? So my x1k plus 1 is equals to this one. Ta-da! Okay, and therefore this is what I have written over here lah. It's the same thing. Okay, neatly. Okay, it's the same thing. Actually not the same thing. I forgot. Alright, is that this thing over here is x1k t over t, right? T minus t and t cancel out, I still have x1k. So I have this one over here. Okay, so this x1k plus 1 is equals to this thing over here. Okay, this particular thing that I just derived, this thing, is the same as this thing. I'll pre-write everything already. Alright, so this thing, if you take a look, is the same as this thing. Okay, and my purpose of me doing this is because I just want to derive to you x1k plus 1, alright, and x2k plus 1. Because if you think about it, your x1k plus 1 and your x2k plus 1, if you go back to the state space all along back in our previous parts, we have written everything in terms of x1k plus 1, x2k plus 1 over here. So therefore I just want to write in terms of the state space, you see. So this is why I'm written everything over here this side. Okay, so I'm actually trying to approach this already. I've coming near that already. I'm coming here already soon. Therefore I'll just simply bring this alright to this side. Okay, so I'll put them all together as one side. That's one equation. Now I will just simply write in terms of a state space. So I will have x1, alright, k plus 1, alright, and x2 k plus 1, alright, and then it's equals to some matrix, and then I'll write as x2 k, sorry, it should be x1 k, x2 k, okay, and then plus some matrix, some vectors I would say, vu, okay, and then yeah lor, and then I have a y, k is equals to something, and then x1k, x2k, Alright, that's all. Plus ju, while this j is 0 ma, still remember? So in other words, I'll just write in terms of this form. This is a standard way of doing this state space, remember? So x1k plus 1 is equals to t x2k. So t times x2k, so I'll just write as t times x2k. And then 1 times x1k, right? So I'll just 1 over here. So t squared over 2 uk. Oh, this is actually uk, sorry. So I have a t squared over 2 uk. Next, alright, x2k plus 1 is equals to 1 times x2k. Alright, x2k. Then tuk is what? Tuk is uk, right? It's t times uk. And then I have no x1, so it's simply 0. And then we say that our boundary condition, not boundary conditions, we own self set. We set it as x1k is equals to yk. Doable. So therefore x1k is equals to yk. So 1 times x1k is equal to yk. While 0 times x2k is just 0 lah. Okay? And therefore if I were to copy this thing, alright, I'll just copy all this chunk and just paste it, where am I? Over here. Okay? You see. This thing over here is the same as this one. This thing over here is equal to this one. This thing over here is this one. You see? You see lah. Aha. But this is a long way, man. I somehow prove to you that having a certain z domain transfer function, as like this one over here, alright, you can actually finally derive your state space as we have shown you over here. The one that we have you know. So in the previous parts of the other videos from 10 or from all these 3 videos, we have proved to you that we use the state space. Alright, we use the state space over here in order and go all the way down to derive to you this one. So in our recent ones, we're talking about the previous video and our current video right now, we actually derive this thing all the way back. Alright, all the way back to your state space. Doable? So we go all the way back now. And therefore this is what we are doing all along, in case you don't know what I'm doing. Okay? check. But anyway, in the next video I will briefly summarize what we have done from the previous video and our current video, because I feel that there's I need to explain it in a way that you can fully understand, because at this video there's a few stuff that you may feel confusing. If you feel alright, then you can continue. If otherwise, you can watch the summary in the next video. Alright, so yeah, see you there.